you will be getting 4 different options, right? So you
Okay.
need to choose out of 4 different options. So which one is the proper one? So out of which, what are all the scenarios that we are discussing? You should able to apply some of your skills. That's it. So
Okay.
can you summarize once the machine learning types that we had discussed and give some examples on that for each type?
Yeah, actually, machine learning are divided into two main parts. So supervised machine learning and unsupervised machine learning. In
These are
supervised
not the
machine,
parts in the machine learning,
it's a
kind of.
types actually.
Yeah,
Types. So
yeah.
there are two types. Yeah, sorry. Yeah. So supervised machine learning will have features and label, whereas in unsupervised machine learning will have only features.
Mm,
And again, supervised machine learning is divided into two. That is a regression machine learning and classification.
mm,
So regression will have the number value. Actually, the
mm,
label will be number, and it
mm,
could have multiple features, and the the label will be in an integer numeric value. In a
mm,
classification, we have binary classification.
mm,
So binary classification means it is like a single, out of two values like true or false,
mm,
zeros or ones, or
mm,
yes, no,
mm. So
those things.
basically, it will be like true or false and positive or the negative. Based on that, you have to get the label values.
Yeah. So
Yeah.
multi-class classification is uh, taking multiple features, and
Mm.
the label also, I think it is multiple only, right? I mean, 2 3 labels will be there,
Yes,
right?
it might be
Mul-
one or it may
m-
change. So here we are
m-
going to group various different features that we'll be getting. So we'll be taking set of
Set of, yeah.
features. Yes.
And
So outcome will be like a label, or we can get the labels.
labels.
Yeah.
And
So I'll
clustering means,
give.
yeah,
Yeah.
yeah,
Tell me. Go ahead with the cluster.
yeah, clustering means grouping similar type of flowers or the birds, or
Mm.
considering the penguin categories itself. But in clustering, we don't have labels, just we will be grouping.
Yes. So here when we talk about the clustering, right? Like so here you got some idea. So based on that, I'll just try to take some examples. Okay. So you are going to predict. So you have to predict the ice cream means ice. I mean so the sale in a based on the previous sale data what you had get. So you need to predict the one of the shop sales in the coming month. So which model you will choose?
It is a regression. It will be sales means it's a number.
Yes. Yeah. And I'll be giving you the fuel. Like I just wanted to give you. I'll ask you to take a ride, transportation. Okay.
Okay.
So based on the transportation that you're going to go with a particular person, taxi driver. So you have to predict the fuel charge.
Fuel charge is again regression only.
Yeah. And yeah. So we had been given you to I just give you the set of flowers, so which you are going to get. Few flowers will be seasonal, and few flowers will be not seasonal. They'll give you every time. Okay. So how you will be means which model you will be using to predict this?
A classification model.
Yeah, in classification.
Classification, the two, it will be multi-class classification.
No, it will come under binary because you have to predict seasonal or not. Yes or
Acha, okay,
no, right?
okay, yes or no, okay, okay.
Yeah.
Yeah, I thought like seasonal flowers will be there, but I haven't
Mm.
understood the seasonal or
Non-seasonal.
unseasonal.
Yeah.
non-signal. Yeah.
So I'll be giving you means I'll be giving you uh, different types of the shapes which are present. Okay, so you have to, and the kind of shapes which I'll be giving, like it will be circle, it will be square, and it will be, see, let's assume that you are going to given, like I'll be giving what is the app expectation is. So there are different shapes of the particular uh, object that you are going to take. Okay, so like star, circle, and then the rectangle, and each shape will be having a different color. So if you wanted to group them into a different parts based on the shape and based on the uh, inside the groups, like based on the colors, so which model that you will be using?
Multi-class classification.
Here, do you have label?
We don't have label. If it label is not there, then it is a clustering.
Yes, so that is you need to analyze first. So
But
if you
here,
can, so
yeah,
I just asked you to group it based on the shapes. That's it. So I didn't give you the actual prediction, right? So you have to predict this. Means there is no outcome I'm not expecting. So only the features which I had given. So you are going to group that. That's it.
in multi-class classification also there are three types of penguins, right?
See, when it is coming,
Prediction.
yeah, I understood. See, when I'll give you the multiplication classification module, I'll give you the example. Like, so let's assume that, so yeah, so I'm going to give you the, so you have to set, when you have to, there are different food varieties. So based on the food varieties that has been cooked on a particular day in the hotel, so the system has to predict whether it is a breakfast, lunch, or dinner, and it should set the alarm. Or it should just notice that, okay, it should predict, okay, this is the breakfast one. So it should predict based on the food items that you had given. So this is a lunch. So based on the food items that you had given, it should predict the dinner. So in that way, it
Okay.
has to predict and give you the outcome.
Okay. Okay. Yeah.
So
Got it.
here you're predicting something from the
Yes.
given features, right?
Yes.
Yeah, that is what. Like here, movies also we took the example, right? So three different movies that we had taken. So out of three different movies which we had taken, so we have to predict. Okay, so whether it is a comedy one, it is a horror one, or it is the like commercial one as such.
Yeah. Yes.
Okay.
Oh,
So if you can do this right, so believe me, you are going to get around 20% of your certification marks you will be getting only with this examples and with this. So here, like around 20% of the questions you will be getting based on the types of the, like that is only simple, these kind of scenarios that you will get, you should able to predict only. So apart from that, you don't get anything much related to the uh, training expressions, those things we don't get much. Okay,
okay.
but
Okay.
based on the model preparation, how exactly we're going to create a model, right? So in from that we will be getting the uh, questions. We will
Okay.
see that. Okay.
Okay.
Yeah, so here we just stopped with this slide in the yesterday's session, so we'll just try to continue from here. So I'll just
Okay.
stop your recording, Nazim.
Yeah. Yeah. I'm recording.
Okay, sure,
I
good.
started recording.
Okay. So here, when we talk about unsupervised machine learning, so we know it is having only the clustering type. So when we'll be having clustering types, that we should remember that we'll be having only features without the labels. Okay. So here, when we talk about unsupervised machine learning algorithms, they will determine the relationship between the different features which are available in our bucket. So example, so we are seeing here the different types of the flowers which are present, right? So we grouped it based on the petals type that they are having. See whether the color is different. I wanted to group it based on the type of the flowers that they are. Okay. So here also color is different, but I grouped similar. one. So we'll take certain parameters which are having similar functionality and we'll try to group them into a specific groups. So here when we are doing the clustering, so we have, so whatever the algorithm that we are using that identifies similarities between the observations that we had been given based on the features, and it will group itself into a discrete clusters, means individual clusters it will try to create it. So when we
Okay.
give multiple flowers, so based on their size, number of leaves and number of petals, okay, so these features they'll consider, they'll group into different groups, okay. And
Yeah.
also like based on the type of similar, it will try to group similar customers based on their demographic attributes and purchasing behavior. So here we have two different features. So what is a feature here? Demographic attributes, so which we are considering as a feature, and purchasing behavior, this is also a feature. Based on this we are going to identify groups into similar customers. So each
Okay.
scenario which you are considering, try to understand which is feature, so which is the label. So here also the size, leave and number, these are also kind of the I can say features which are having,
Features. Okay.
okay. Yeah. And also sometimes in the exam, how they will be giving you the questions, right? They will give you the list. Okay. So, okay. So you are having a list of features. So I'm going to have the temperature and I'm going to have the particular mass of the particular value. And based on that, I'm going to um, find out category price. This is one of the example that I had seen. So here what happens based on the question is, so based on the feature, so you are going to identify the category price.
Okay.
Okay. So here the question is, so there are three different statements. You need to say yes or no. So this is yes you have to tick, this is no you have to tick. So first
Okay.
statement is, so here the temperature is the feature.
Yeah.
Is it correct?
Yes.
So yes, obviously, even though they had not mentioned that feature's name, but temperature is a feature which we are going to use it to predict. And here, the category price is the label.
Yes.
Yes. And here, mass is the label.
Mass is the label feature. Uh,
Is it true or false?
Temperature, mass. Uh, CPE. M is
It
mass
is
is false.
actually
It's a
false.
it's a it's a feature.
Yes, feature. Because they mentioned only we are going to, based on the feature, we are going to predict the category price. It is clear. The label is category price.
Um,
Correct?
yes.
Yeah. So in that way, you will be getting. So, and
Okay.
also when you start with the exam is one suggestion, whether you get it or not, you will be having exactly 65 minutes. So
Okay.
sometimes you will be having questions count from 40 to almost sometimes 30 you will get, so to 50, sometimes more than 50. Okay. You to
Okay.
read this many questions only it will take you approximately 50 to 55 minutes.
Okay.
So try read and start selecting the answer because you don't have the negative mark
Yes.
after that. And also there are certain places where you need to drag and
Yeah.
slide your page. Make sure that you are going to do that because you may miss some of the places to answer, right? That's why just make sure
We
that where and all scroll is there, you're going to scroll down and complete the sentence like that.
okay. And we cannot go back to the previous
You
question,
can go
right?
back, you can go
We
back,
can
that's
go
what
back.
I'm suggesting. Like you will be getting 50, you try to target to finish all the questions by 55 minutes.
Okay.
So after that you just go back and review your answers. So when you do that you can just more confident, and sometimes you can, now you are tension free, right? So you can
Yeah.
rethink and you can try to correct your answers.
Okay.
Okay,
Okay.
so
Yeah.
this logic you should be remembered. And you booked the online or offline?
Offline. My my home is having a lot of
No
things
problem.
actually. So
No problem. Yeah, yeah, you go reach center around 30 minutes before. So make sure that the instructions and all read properly, because they wanted to verify your ID card and all properly.
yeah,
So yeah, so go through that.
sure.
Okay, yeah.
Yeah.
So here in the unsupervised, so we are going as such. So yeah, in some ways we can see multi-class classification and clustering is similar, but only difference is like when we are having multi-classification module, so we are going to have certain labels. Okay, but whenever it comes to the clustering, so we will be not having any label. Okay, so
Yeah.
it's like we are going to use our algorithm itself identify the similar features, and it will itself try to categorize the features based on the given format. Okay, yeah. So this is like complete. So till now whatever we discussed, right, so it's the same we are having. So whatever the regression models when we are using, so they are trying to predict the numeric label values. Okay, so based on whatever the train means, whatever the data set that we are preparing, right, to
Mm.
train a model. So first thing always, so we have to prepare the data set.
Okay.
Okay, so once we set do the data set, then we are going to train a model. So which algorithm that I am going to use, so I am going to use it. So once I train the model, then I need to register my model.
Okay.
So after that, I supposed to evaluate my model. Means I need to validate whether it is able to fulfill the required needs or not. Then I need to review my model. So there are some expertise who are present, right? So I can just ask them to review my model. Okay.
And deployment will
So
come here.
usually, yeah. So like whatever the deployment, when after training the model, so we can try to create a job. So in that format, we can try to. I mean, whatever the job creation is done, so we can try to deploy our model as well. I'll tell that flow.
Okay.
Okay. So here we are going to predict the uh, numeric values based on the whatever the training data that we are having. So they includes both features and the labels in the when whatever the data sets we are using. So in the data sets also we'll be using the label values as well and features as well. Okay,
Mm.
so without features, we don't create our data. So whenever we are creating a data sets, we'll include the label as well for that. So with this parameter, if this is the label, so based on that, we are going to understand what exactly the actual model output is as well. Okay. So here to train a model, evaluate the model's predictive performance and refine the model by repeating the training process with different algorithms and parameters until you achieve the acceptable level of predictive accuracy. Like whenever we are following this, whenever we'll be training the model, right, there
Yeah.
is actually one approach with the data sets which we'll be using. So whatever the data set that we are using, right, so we don't take completely all the data sets whichever we are getting. So usually 70% of the data that we'll be using just for the actual evaluation. Okay, so in 30% of the data, so we can have it only for the evaluation process, like testing process only we can try to use it. So it is because to include all different values means make it proper testing here, uh, to take uncertain scenarios and predict the values how exactly it is going to work. So for that reason, so we'll divide our data set into 70 into 30.
Okay. The 30% is the real data or it's a What type of
It's
data it
in the
will?
real data only, so we'll try to segregate into in this format 30 70 into 30 format. So
Okay.
what, because when you are testing each time, right? So okay, let's see how, before you evaluate your model, so whether it is reaching the expected, like either if you are taking it to register your model while training only, sometimes you are going to validate whether it is going to give the expected output or not, right? So
Yeah.
during that time it is not possible to, if you are having thousands of the record, so is it possible to test with all the records?
Might be not possible actually because lot
Yeah,
of
so
data.
yes. So for that reason, what we'll be doing is, so we'll just take the actual 30% of the data and we'll predict it. Like, so whether it is going to give me the expected outcome or not based on the algorithm. So we are going to evaluate it. So after means multiple times we are going to do that, um, by adding different algorithms and different parameters we are going to add until we'll get the acceptable predictive accuracy. So once we get the acceptable accuracy, so then we can try to test with the 100% of the data which we are having.
But 30%, even 30% data, is it, if it is perfect or not, the model,
Actually,
whatever it is
like
returning. Yeah.
what exactly the standards will refer, right? So if you are testing with 30% of the data, it will work for the 100% of the data as well. So in that way, so they will always try to take it this 30% data for the testing purpose. Means this is one of the best data set that you can segregate while setting it, because we had seen certain responsible AI, right?
Yeah.
So in that also, when we are doing, if I wanted to have safety and reliability, so we should try to handle all the different errors and different types of the data sets we should try before I'll develop my actual model. So accordingly, so we should do all different types of the errors that we can get. So like you can give different data sets and you can try to validate, okay, so in these scenarios what is the outcome that I'm predicting. So in that way we can try to test that predictive accuracy, so whether it is able to predict 100% what I am expecting or not. So for that you are initially using only 30% of the data.
Okay. Okay.
Okay, yeah. Okay, so here four key elements of the training process in the supervised machine learning. So this we know, right?
Four key elements are supervised. Okay.
So what are these? Preparing the
Uh,
data set,
yeah,
training the
preparing that.
model, or we can choosing the algorithm. So then we, whatever the function that we'll get, so we can try to predict the value. So here means this we can make it as training, inferencing, correct?
Yes. Yeah.
Okay, so here they had given related to the linear, um, so the regression one. So here, first thing, we are going to split the training data randomly. So this split is what I told. That is one of the standard way of splitting the data is 70 to 30%.
Okay.
Okay.
Yeah.
So we'll split the training data randomly to create the data set with which the train the model while holding back a subset of data that you will use to validate the trained model. So it's like we are going to split that and we are trying to create a required model which I wanted to means while training to predict that. So we'll just split and we'll try to use that particular subset which I had been split to validate the model whether it is giving the expected outcome or not as such. So
Okay.
after I just did the split, so I'm going to use the algorithm to fit the training data model. So like whatever the algorithm that I'm going to use, whether you wanted to use the classification, binary classification or multi-class classification or regression clustering. So whatever the algorithms are required for you. So we can try to use that algorithm which is going to fit this trained data model. Okay, so here, like, these are the different stages. So whatever the data set that had been pulled, so we are going to split that to evaluate the data set, means training the exactly the with the data set. Then so we are going to use the algorithm, okay, to fit that particular trained model, means to extract the data set based on our uh, algorithm which I'm going to use. Well, if I'm using the regression, so I can take it up the regression model, or if I'm using clustering, I can use the clustering. So then we are going to validate the data. So you held back to test the model by predicting the labels and features. So here, whatever the split that we had done, we might have split into 30 and 30, 70 and 30%. So we can use this 30% data by applying the algorithm to make sure whether it is going to predict as expected or not by applying this algorithm. Okay.
Okay.
So
Okay.
after that, we are going to compare the known actual labels in the validation data set to the labels that the model predicted. Like when we after prediction, what exactly we'll do? So it will predict and it will give me some values. So whether it is matching with the actual predicted values or not, we are going to verify it. Okay. So whatever these predicted
Sorry,
actual, tell me.
sorry, Amanta.
No
So,
problem.
compare the known actual labels. So whatever the model has predicted,
Mm.
the labels we need to
See
compare with.
this. Yes. See, this one, while predicting, you are going to give certain features, new features,
Yes. Yes.
correct? So when you are giving the new features, so it gave some it predicted and it gave the outcome. So
Okay.
you are going to compare with already in this whatever the data set, whatever the predicted values are there, right? So in these scenarios, is it the expected outcome in my model or not?
Okay. With the 30% data set,
Data set it you
with
has
the
segregated. Yes.
okay, predicted will be
Hmm.
compared with the 30% data set.
Yeah. So whatever the data you are trying to use it, so it will you will try to check. Okay. So whatever my label means outcome that I got now, so already stored label whether it is matching or not. So if it is matching, we can say 100% accuracy that we are achieving, right? So for the
Mm.
validated data, so I can just try to use 100% prediction is proper. Okay. So
Okay.
in this way, after each train, so we are going to validate and then evaluate iterations. So this will be repeated till we'll get the achieved prediction count. So here you can try to give other set of values. So verify whether it is predicting or not. So in that way, we can try to take different types of the data set. We can make sure whether the prediction is correct or not. So in that way, we can make sure, okay, my model is giving me the expected outcome or not. See, these are all you no need to go out. You can directly do from the Azure Machine Learning Studio only.
Okay. Okay.
Okay.
Yeah.
Okay.
Okay.
Yeah. So here there is a in depth about the classification model which we had discussed. So when we talk about the classification model, so binary classification, so we know it is a supervised machine learning technique which it is going to use. So here it also follows the same process. Like, see, all the process is same, Nazim, for all the model. So training, validating, and evaluating. So first we are
Okay.
going to train the data set, means we are going to train a model. Then we are going to split the data. So after that we are going to validate whether it is going to predict or not. So means then we are going to evaluate the models. Means when we are evaluating also, we are going to use different statistics. Okay, we can see what are the different types of the statistics are used in the Azure. So for each different model, the statistics will be, it means whichever the algorithm that you used, whether it is a classification, linear, regression, so the statistical values will be different. So let me quickly show
Statistical,
you
sorry, can you come back again on statistical values?
statistical values. I'll show you. So a value Azure regression. So these are the one, like you will be using mean absolute error, like whatever this outcome it is coming, right? It can show me the actual and predicted and above the number of observations. So these are different types of the in this way we can use like
Metrics.
mean absolute error, different types of the root mean square error. So with this I'll be getting the prediction. Okay, so when I'm evaluating, so these are certain parameters which are used to evaluate the models that we had been created. This I'll show
Don't-
you when I'll be creating the uh, ML model when we want, when we'll try to create it. Okay,
Okay.
but you got some understanding, right?
Yeah. So this basic, I mean, whichever model we want to predict, we want to predict labels based on some model. It has to go through the training, validating, and evaluation of models that I have got. And as you
Mm,
mentioned, the statistics.
mm,
Statistics again, while evaluation, it
mm,
model will follow some statistics internally. Some
mm, mm.
so
Yes,
those statistics are like the one which you mentioned, mean something
yes,
absolute. Yeah. Is it
yeah,
what I understood is correct or
yes, yes, correct.
okay? Okay.
Anisha, sound kamedu.
So evaluating the model internally, it calls all these metrics that you mentioned.
Yes.
Okay. Then only. So iteration again, as you mentioned, again, if something goes wrong, I mean
Mm,
the what is it? The prediction is
mm,
not to that extent. Again, we reiterate, modify the sorry, what we can do next? Modify the data set again,
mm.
then train, then validate, and then reevaluate. Again, the process will be
Yes.
going.
Till till you are able to get the accuracy in your model, right, which you are creating. So you will be keep repeating this one.
Okay. So we need to
So for
continuously.
all the, yeah, so for all the models, so until you will get the exact predicted value, so you should keep training, validating, and evaluating the models which you had been given. But so this calculating numerical values like regression module. So as instead of regression model, so we'll be using here the classification model, right? So they will be giving you the probability of the values like expected values, so base predicted values, so based on this model.
Okay.
Okay.
Sure.
So as we know, so when we are using binary classification, we'll be getting true or false as the outcome. So one or zero or positive or negative, we'll be getting it. So here there's the one of the examples that I'll get. So when the blood glucose level, if I wanted to identify, so based on their blood glucose level, I wanted to predict whether they are having probability of getting the sugar, diabetes or not. So here,
Yeah.
if it is a particular range, I'll be giving you, right? So if it is 67, so he don't have the probability. If it's 1 or 3, he's having a probability. It's kind of, now you can observe here, if it is more than 100, they have the probability.
Okay. Yeah.
So when is less than 100, they don't have the probability. So in that way, this in the when I apply this algorithm, the data outcome will be coming in the form of 0 or 1 as such.
Okay.
So the same way, multi-classification model. So this we know. We'll complete this and then I'll take you into the slide window, Nazim.
Okay. Yeah.
So when we use the multi-classification, so here also whatever the as we'll do for the for the classification and binary classification and regression. So same iteration we'll try to do: train, validate, and evaluate process only will follow. So here, its only thing is whatever the algorithm calculations it is going to apply, calculate probability values for the multiple class labels is different. Okay. So
Yeah.
here we had taken certain parameters like different, yeah. So as we told, so if here the outcome, okay. So if it is 0, it is based on their size when we are getting the based on the observation. So if it is having a certain, we are going to give the label as 0, 1, and 2. So each label will represent one species. Okay. So
Yeah.
based on the flipper, that length of the flipper which it is present. So if it is having certain range, so here we can see if it is between 100, okay, yeah. So if it is having more than 150, okay, 160 I can consider. One,
Yeah.
not even 160. Might be I can consider 170. So if it is less than 170, then it is 0. Means it is Adeli. Okay. So
Okay.
here this is Adeli less than 170, and yeah, so here less than 180 I'll consider it is. So
Yeah.
this is also Adeli and this is also Adeli. So when I consider more than this 197, it is having Gen 2. This is also having Gen 2. Okay.
Yeah.
And yeah, so the more than 200 if I consider. So these are all having 2 as the predictable chinsta. So here rather than yes or no, so I am going to make it into different types of the species based on the different grouping or the length as a parameter when we'll be considering.
Okay. Yeah.
Yeah. Uh, Give me 1 second. Can
Mm.
you? I don't. My daughter just went out. I'll just have to check her.
Okay.
1 minute. Sorry, Nazim, I'll share my
Yeah,
screen.
no problem.
So when we are doing clustering, so here we are going to group this, which are all the data that we are using. So based on
Mhm.
the similarities which we are going to get it. So here, when we are doing, we don't use the label. Okay. So
Yeah.
I mean, we'll be using a different clusters we'll be getting, right? Different subgroups we are going to do that, right? So here that subgroup only we'll consider it as a label.
Okay. Here
Okay,
we
means
don't have the.
whatever, yeah,
Yeah.
so we don't consider the predicted outcome, but what is the outcome for me is like the group of features which I am going to create, will consider them as a individual clusters. That cluster itself acts as a label.
Okay. So
Okay.
since
Hmm.
there are different flowers, we have categorized. We have grouped uh,
Hmm.
each flower with a count actually. Count or
Hmm.
just we have grouped, consider like we have
Hmm.
grouped. Now these
Hmm.
features which were
Hmm.
grouped, they themselves called as labels. A bit confused
Yes.
actually here.
See, yeah, yeah. So here, what happened is we can just whatever the different ways that I can group is, right. So we can try to based on the different whatever the features that they'll be giving. So we can try to group them into different clusters. Okay.
Yeah.
So example we'll see here. Here they had given the different flowers. Okay. So what they are telling is they had given two features, means features are here the leaves and the petals, number of leaves and the petals. So based on the number of leaves and the petals, we have to group into similar flowers, we have to group into different clusters. So when I am uh, clustering, so here if I take the leaves, okay, so there are whatever the zero group that we are just taking, so we are going to have the five.
Leaf, leaves,
Yeah,
leaves and
sorry, yeah,
petals means for roses.
leaves.
Mhm.
Yes. So here if I take without leaves, so this is the one. Okay. So this is having the petals as the five, six it is having. So based on the leaves, when number of leaves, if I consider, this is also having zero, but it has five petals.
Yes.
So these like without leaves, this is one cluster it became. Okay. But
Okay.
in the same way, when I take based on the leaves count only, so which is having one leaf. Okay. So here I have one, two, three, and four. There are four different flowers, right?
Yes.
So in the four different flowers also, if I wanted to count the petals, three, three, here six, and then here it is almost eight. So here I have
Mm.
three, three, six, and eight, which is having. And another group that I can do is with two um, leaves.
Two
So
leaves.
here we have two leaves, and here I have, so I have eight and seven almost. Okay, so in this way, we are going to group based on the similarities which we take.
Okay.
So
Okay.
these are like different uh, clusters which we are going to create, subgroups.
Okay.
Okay, yeah. So here, when we wanted to train the clustering model, okay, so we'll be using the most common algorithm. There is a inbuilt algorithm that uh,
You
K.
mean
Okay. So
okay.
this is like clustering only. Okay. So when I
Mm.
wanted to train this particular prepare clustering model, so these are the different steps that we'll be using. So if I wanted to do the regression, so these are the different key elements when I wanted to follow the regression model. So in the same way, when I wanted to do for the clustering, so these are the different steps that I have to do to train a model.
Okay.
So here first, so the feature values which are there. So we have to take this in the form of vector, means kind of n dimensional coordinates. Like I might be having multiple values, uh, multiple different types of the features will be having, right? So I can take it in the form of vectorized form, so which are all the values that I'll be taking. Like here, as I told, like we can have it as the key value pair, right? Like I'll be having different leaves and also different number of the petals which I'll be taking. So based on that, like we can, these are all two different. If I, even if I consider this is like kind of a one particular group, so this is also one particular group. So we can try to take it into different vectorized format, like n dimensional coordinates. I can try to have the values.
Okay. Okay.
So once I decide, okay, so I should go with this particular features and in this particular format, then we have to use the means we need to group that and make it as a many clusters that I wanted to use that particular flowers in the groups. Like as I told, so based on the number of leaves, so I'll be having 0, 1, and 4 based on 0, 1, 2 petals. So I had grouped into three different groups. So how many groups that we had been divided? So we can try to use a k value to represent for that.
Okay.
So here, if I'm using three different clusters, I can take the k value as 3. It depends like how many clusters that I'm going to create it.
Okay.
Okay.
See, cluster means uh, there could be only features in the data set.
Hmm, hmm, hmm.
So each feature represent each category. Each category means
Yes.
the petals and the
Type.
leaf
Mm,
type.
yes.
Okay. Okay. Yeah, please go ahead. I will revisit this uh, to understand more. Actually, I got
See,
just to revisit.
what I'll suggest you is, see, you understand why it is used. Okay, that's
Yeah.
it. So apart from that, you don't, no way you will get the terminologies related to preparing, training the clustering model, training the regression model as such. Okay,
It's
but for
somewhere
your
I saw
understanding,
it's
mm,
K plus something. K
that is
means
different.
somewhere I saw this
Yeah,
one.
so usually came in which you are, which type of a model that you will be using, you might be getting. You
Okay.
might be right like that. Okay. Yeah.
Okay.
So once you are going to segregate into different clusters which you had been divided, so that whatever the uh, k that you had been plotted, right? So with that k, so there are associated values which are present. So we are going to have whatever the k plotted values are there, k points are there. So with that, you are going to build a random coordinates for that particular cluster which you had been created, that value which you had been set up. So for those values, we are going to say it as a centroids, which we are going to, means like how exactly we are going to get that particular centralized value, means kind of a grouping that we are going to do is, right? So with that reference, we are going to have my centralized grouping cluster. So this is a major clustering part which we are going to use to group the specific values. So this we are going to use it as a centroids
Okay.
to group, to segregate into each cluster. So these are the actual clusters which we are going, cluster types which we are going to use it.
Okay.
So each data point which we are having is assigned to its nearest centroid. Means as we are using uh, 0, 1, 2 clusters, right? So whenever we are taking features as well, so which is matching with the particular cluster, we are going to assign to that particular cluster.
Okay.
So
Mm.
in that way, we are going to have certain inbuilt algorithms. So which is try to group that into the different whatever the data sets that we had been prepared. So Means we are going to have the data points to which particular feature which I am going to consider, to which cluster it belongs. So in that way, we are going to, by adding to the closest centroid, by moving that, so we are going to make it a stable uh, relationship between the different groups that I am going to create it.
Okay.
Okay, so
Mm,
maybe I'll just show you with the model how exactly we can do it by taking some example. So in that way, you will be more clear with this. Okay.
yeah.
Yeah. So here, this is the simple diagram. So which represent, like, as we talked about the petals and the groups, right? This is one feature. So here we can talk it as the number of leaves. So here the petals count which we take. So we are going to make this as one cluster. So as they are having, so between 2 to 4 petals we can say. So here
Mm,
between this point, okay. Yeah, so 4.5. If I take this particular range, so 5 to, so 6, we can consider it as a one cluster. So 7 to 8, which is present, is considered as a one cluster.
okay.
Okay. So we'll
Yeah.
just try to see for each type one examples. Okay, by building the
Mm,
model.
okay.
So evaluating a, this is when we are using the evaluating the, to when I'm trying to evaluate. So we'll be using multiple metrics. So here average distance to the cluster center, average distance from the other center, and maximum distance to the cluster center, and sill out. So these are the different parameters metrics which we'll be using to evaluate the model. Okay.
Okay.
So
Okay.
as of now, you just have to remember the terminologies. So when we'll try to create a simple model, right? So then we can try to correlate the things.
Sure.
Okay? Yeah,
Yeah.
sure. Nazim, I'm having one more call at 8:30. Can we connect tomorrow?
Yeah. Fine.
Okay,
Fine, Manta. Yeah.
sure. So what I'll do is I'll try to connect quite early, like 7 o'clock only exact. We'll try to connect so we can try to cover all these models uh, simulation. So once this steps, if you're clear, so we can start with the next module, vision related one.
Okay. Okay, Manta.
Okay. Yeah,
Yeah.
sure, Nazim. Yeah, thank you so
Yeah.
much.
Yeah. Thanks.
We can
Thanks.
connect
Bye.
back.